Hello and welcome to the Plant Design for Food and Beverage Facilities session. I'm Chris Parkin, Principal Software Consultant based in the UK. In this session, we'll have an overview of some existing projects completed in the food and beverage industry, look at modelling with BricsCAD BIM, creating equipment with BricsCAD Mechanical, and completing the process design with CADWorx. CADWorx and Analysis Solutions covers many industries. In this session, we'll focus purely on the food and beverage sector. Here are some examples of where CADWorx has been used in the food and beverage industry. This is an ice cream facility in the US, and Dennis Group were one of the early adopters of CADWorx in the food and beverage industry. Now we have a dairy processing plant in the Netherlands, where CADWorx is used to increase capacity in an existing facility. Now we have a distillery expansion in Scotland, and we also have a winery in California. We've looked at some food and beverage projects that have used CADWorx for the plant design, but what else is required? We also need the architectural design of the building, as well as the specialist mechanical equipment. Fortunately, we have a solution for both of these design disciplines too, working in combination with CADWorx or separately. So looking at the Bricsys product suite, we're focusing here on BricsCAD BIM and BricsCAD Mechanical. We'll start off with BricsCAD BIM. BricsCAD BIM is DWG based, and it's useful for anyone who needs to work with a building model whilst developing plan design models and our mechanical equipment models. Looking at the design integration, we have our BIM and mechanical design inside BricsCAD, alongside CADWorx, all in one DWG-based design environment. And if further design collaboration is required, both BricsCAD BIM and CADWorx Design Review include IFC capabilities. Now let's look at the BIM workflow. So we have a partially complete building model. We're going to hide the roof structure and hide the beams. We can then use a section plane to hide the wall. We can temporarily hide this floor to see the layout of the floor below. And now use Quick Draw to add some rooms to this floor. We'll start off with a large room in the corner, followed by a small office. We'll add another large room. And just separate this out and add in another office. We'll make the final room and then adjust this wall around the stairwell. Before adding in the final wall. We can then adjust the connections between some of these walls. So we can see these are mitered. We'll adjust them on both ends and then delete any walls that are not required. We can also adjust these walls to end at the same point as the floor below. If we orbit around, we can see the slope of the roof, and we can see that our walls are too tall. If we select all the walls, we can trim them based upon the slope of the roof, and then trim any excess. We can move on to add some BIM components. Let's add in a door to one of the offices. We use a single swing door. We'll choose the wall, and then just choose a location along that wall to place it. Flip it 180 degrees so it opens the other direction. Continue on, add any further doors as required, before adding in some windows. We'll use a 3x1 window. Again, we choose a start point and a dimension for the window. We can also place windows by placing a simple rectangle, adjusting the location of the rectangle, and then replacing it with that BIM component of a window. We can then change some of the properties of the window. So we'll change the thickness of the left, middle, and right panes as needed. Once the windows are complete, we can move along to add some railings. We'll choose a start point, and then we can modify these railings, the length, the height, and the number of bays. We'll place a second set of railings. We'll turn the section planes off, and we'll unhide all the components. We can now review the element classifications. Now, some of these require updating. We can use Binify to update this. Looking at the new elements, we can select the internal walls. Currently, these are set as external. We can change this so they are internal walls, and then use BIM Classify to update them. We can now use section planes to see the inside of the model before applying compositions. So we have concrete floors, external and internal wall compositions. Once we've applied them, we can use Propagate to assign the same composition to all similar elements throughout the BIM. Before turning off the section plane, we use another section plane and now look at the connections between the floor and the wall. We can see that this needs updating. So we need to change the joint composition, and we'll update some of the plies individually as needed. Once a single joint has been updated, again, we can use the Propagate option to propagate that same joint composition across all wall-to-floor connections. We can just accept them on this right-hand side as well. And if we zoom in, we can see the same joint composition on this side. We'll turn off the section plane, and now we'll look at creating a floor plan. So we can set the scale, generate the floor plan, and open it up. We just need to automatically assign the tags, and again set the scale as needed. Before the floor plan is complete. Now, the plant design in the food and beverage industry has many unique requirements. Things such as custom vessels and specially designed equipment, things such as mixers and blenders. For example, in the list on the right-hand side, we can see some of the custom equipment that is needed inside the food and beverage sector. We can now look at creating one of these custom vessels with BricsCAD Mechanical. In this case, we'll place a sphere, a cylinder, and then take the intersection of the two solids. We can then fillet the edges, change the height of the vessel. We can make it into a shell. And we can see the wall thickness as well. We can then use thicken to create the body flanges at the top of the vessel. Before inserting some bolt holes onto this flange, we'll place a single bolt hole first of all, and then use a polar array to create all the bolt holes. We can then insert the second flange, and move on to inserting some more items such as a leg. Once we've added one leg, we can use polar array to create the 4 required legs. These legs need rotating 45 degrees around the centre line of the vessel. And we can now continue on to insert nozzles. This first nozzle has a blind flange, so you can place a second nozzle tapping into that blind flange. We'll place a couple more nozzles before adding the final handhole nozzle on the top. On the underside of the vessel, we need to insert some clamp connections. One is directly in the centre of the vessel, one is offset slightly, and will be rotated 45 degrees around the centre line. Moving back up to the body flanges on the top of the vessel, we need to bolt this together. So we're going to insert some nuts first of all, one on the top, one at the bottom, and then add threaded bar to connect this together. And we can adjust that as needed. Once that single bolt is complete, again we can use a polar array to insert all the required bolts. So the vessel is almost complete. We need to add in some further items, some assemblies also created using BricsCAD Mechanical. First of all, a homogenizer, a high-speed mixer, and the main mixer assembly. And that is the vessel complete. Now, as well as creating new vessels in BricsCAD Mechanical, we can modify vendor-supplied equipment models, such as this pump. In this case, we want to add a safety guard around the shaft and coupling. We'll start this with a rectangle that is extruded to form a solid and stretched just to the pump base. We can then form this into a component and save it as a separate file. We can then open this safety guard. We can make it into a shell by removing these 3 faces and then convert it into sheet metal. Once converted, we can add flanges, change this lofted bend into a bend, and then unfold the body. Once it's unfolded, we can add in some components such as this slot. Just rotate it 90 degrees. We'll insert a single slot along the bend area and then use a rectangular array to add all the slots required. We can then show that this updates. We just need to add in the bolts as well. So just 2 bolts on the left and 2 bolts on the right. Jumping back, we can see the original file has been updated with the new slots and holes. We can change the colour, save that file, and update the safety guard in the original file. We need to add some further items, so we need to bolt this down to the pump base. So we're going to add in some washers on the top, a bolt, and on the underside, another washer, and a nut. We can then copy that small assembly to the other hole on this flange. And to the two holes on the other flange. And that pump is now complete. Let's now look more closely at how CADWorx addresses the sanitary design for the food and beverage industry. So CADWorx enables the efficient routing using pipe rules to automate the selection of the correct gaskets, bolts, clamps, etc. for any custom connection. CADWorx supports multi-port valves, which have a variety of connection options and are often supplied as an assembly. Other requirements for sanitary piping include separation of incompatible fluids, slopes for complete system drainage, and so on. CADWorx includes a comprehensive library of sanitary and high purity components, over 10,000 components in fact. We're only looking at a very small subset here, from a variety of vendors, including Waukesha Cherry Burrell, Tugendhagen, Alfa Laval, and Sudno. Let's look at modelling in CADWorx in more detail. So starting off with a partially complete CADWorx model, we'll extract in the bin model created earlier. We'll generate a section plane on the roof, so we can see where the CADWorx model is located inside the building. And zooming in, we can see the CADWorx model pretty much fills this whole room in the facility. So that we can see it more easily, we'll just attach the X-ray. Now we can X-ref the vessel that we made earlier. And we can see it at the front of the model. If we orbit round, we can remember that we have clamp connections on the underside of this vessel. Let's also X-ref in the pump we made before. And we can see that this particular pump has flange connections, not clamp connections. So let's make a change to it. We'll swap the impeller housing from a flange connection to a clamp connection. We'll also add in a generic nozzle, add that discharge nozzle, so that we can route up to it with CADWorx. We can reload that updated pump. And then X-ref in some piping. So we have some piping that goes between the vessel and the pump, and also the vessel and the edge of this particular room in the plan. We can also add in some new piping. Using the spec view palette, we can just select tubing, connect up to the nozzle, we can add in a fastener component, we'll just use a clamped ferrule connection, we'll come along sideways about 1/2 metre, and then drop down in elevation. Line up with the pipe already coming from the vessel, and just route to the edge of this room. Zooming into the clamp, we can see currently we're using a solid mode. We can actually convert this to enhanced to see more detail of the clamp. Moving to the top of the vessel, we have a partially completed line that goes to the top of this large vessel. We can use the plus script to continue on from the T. We use the same line number. We'll change the elevation. And then we'll choose a welded elbow 90 degrees from the line. Now this line will be sloped, and it will be sloped 10 millimeters per meter. We can just route it around. This needs to go about 7 meters in this direction. Then it will come back around about 6.5 meters. This also makes it very easy to see the slope of the line. Before we look at connecting up to the pump at ground level. CADWorx presents a variety of route options. We'll choose the required route and all the connecting components. Once the line is complete, we can then generate our isometrics. On the isometrics, we can see the slope of the line, and also we can see the connection to the nozzle at the bottom. To conclude, CADWorx is perfectly suited to design your next food and beverage facility, and it can efficiently meet the engineering and design challenges you face when delivering projects to your client.